Good afternoon, everybody. Welcome to Monday afternoon of Chem 1105 with your host, me, Dr. White. Let me remind you, tomorrow we will not have a Zoom meeting because it's 4th of July tomorrow and there's no classes. So I'm not going to have a class. Now, before we get into today's stuff, I have something special to show you. Grand finale. Now, you might want to wonder why I showed you that, besides it's really cool to watch. That's chemistry. When you see fireworks exploding and the different colors, that's electrons moving from shell to shell. The energy from the explosion moves the electrons to an outer shell. When that energy is no longer there, they come back to the shell they should be in. And when they do that, they give off energy in the form of light. And different elements, or really it's cations, have different colors. My favorite is red, and that's from strontium salts. But anyways, when you watch the fireworks, if you're going somewhere where they are, you're watching electrons moving from shell to shell. And you can tell all your friends and neighbors and loved ones that. Now, people don't want to hear chemistry during fireworks, but don't forget, tomorrow's the 4th, and there'll be no Zoom meeting. I don't know about you, but I'm going to be with family. We're going to have a good time together on the 4th. All right, today's game plan. 1, I'm going to do the lab. Then I'll go through test number 1 material. And then when we got still time left, which we should, I'll go back to chapter 5. So what I like to do first and get it out of the way is do the lab. Normally we'd have the lab, I guess it'd be this way, tomorrow, but there's no school tomorrow. So we're having it today. And if you see on your screen, here's the lab, periodicity, say that 5 times quickly, and the periodic table. And that's today's lab. Now, for today's lab, in your kit, and getting mine out of the plastic bag it was in, here's the bag it was in. You'll be using these cards right here. Now, if you look at it, it looks like the Monopoly cards and get out, different cards from Monopoly, but it's not. Those that haven't played Monopoly, you're missing something fun. But anyways, you'll be using these decks of cards. Now, one thing I want to log into Blackboard. All right, what went wrong? All right, we go to the assignment area. And I'll make sure you can see it. And you can. You'll see the lab 7 that I'm going to talk about. Now, at the bottom, don't forget to have a selfie. And actually, you're going to do a lot of photographs for this lab. But notice here it says, please do not answer any lab report questions with the words classmate in it, but do the tables for your own cards. Again, don't answer any lab report questions with the word classmate in it, where you have to get data or information from your classmates. Just ignore that. All right, let's go back and look at today's lab. Now, here's the different decks of cards. And what you'll be doing is looking at how the periodic table was developed. And eventually, it was Dmitry Mendeleev, that great Russian scientist, who actually came up with the periodic table we use today. However, if you read the background, and I'm not going to go through it all, a lot of other scientists, I don't even know back then were they really called chemists yet, were working on developing a way of organizing the different elements in a tabular form. And you can read about how there were different attempts that came close, and finally Mendeleev was the one who came up with the one we use today. And when we look at a periodic table, there are different ways of organizing it. When you look at it, and let me open mine right now. Hold on, or don't hold on. Here's let me make sure you can see it. You can't. Here's our modern periodic table. The one you use doesn't have the names on it, but you have some elements, and you can look at it in columns, and you can look at it in rows. And different ways you look at it, there are different trends. And you'll be investigating those different trends today and going through how did oh, I'm looking for it, and it's part of my PDF. Sorry about that. How did Mendeleev come up with the periodic table? Now, as you see here, you got card deck 1, 2, and 3. Now, since you're working with the decks of cards, this is the only lab other than the balanced chemical equation and safety lab where you do not have to wear safety goggles or gloves. Hopefully you're smart enough not to get injured by cards like this. And they don't even have sharp edges. So I don't think you'll get any paper cuts. Nope, you won't, or you shouldn't. All right, now you need a flat surface. You'll need a cell phone or some camera. And what you'll be asked to do is different activities. Now, in the first activity, you'll use deck number 1. Deck number 1. And you'll look at that, and if you look at they have different shapes, different numbers, different colors. And you can organize them based on a certain grouping you decide. Now, record this, you'll choose one characteristic, shape, color, number, etc., and arrange the cards accordingly to the chosen characteristics. Like you could put all the yellow ones, purple ones in one pile, blue in one, and I don't know, you call this not really red, I guess sort of a pinkish color in another. And then you go back and do the same thing with another characteristic. And photograph the arrangements of cards you have in set one. Without disturbing, remove 2 cards at random, place them aside, and then show the blanks and follow the instructions. I'm not going to read through all this. You can do it. It's pretty straightforward. Now, in step 2 or activity 2, you'll be using card deck 2. And here, if you look at, they have atomic mass on here for the different cards and other information you'll use later on. And you'll follow the instructions here by placing the cards in different groups. Remove the card, by the way, in step 2, mass 1 and mass 4, set them aside for 8. Follow these, then pick up the 2 cards and arrange them in a pattern or trend you've observed. And take some pictures of it, as they say here. And finally, in step 3, well, not finally, in step 3, you'll use deck 3 cards, which have now a lot of information plus the elements names at the top. And you'll follow instructions like in step 2, they tell you remove hydrogen and helium and set them aside until step 7. Stack the cards in 8 groups on the basis of their valence electrons and place the stacks in order rows so that the elements with 1 valence electron are to the left of the elements with the 8 valence are to the right. So you have 1, 2, 3, 4. Hint, look at the periodic table. Oh, I gave it away. And you'll follow this, do step 7, place the hydrogen above the lithium and so on, and the helium above the neon. Then observe any trends or patterns and photograph it. And then for activity 4, you'll use the data from deck 3 to prepare visual representation of atomic radius, first ionization, energy, and electronegativity. Now, on the cards, they have ionization, atomic radius, and so on. So you can, oops, drop my cards. You can stack them and arrange them. Now, I have talked about electronegativity. Atomic radius is what's the radius of that element's atom. And a radius is half the distance from the center of the atom to the outermost electrons. And the larger the radius, the bigger the atom for that element is. Now, the first ionization energy tells you how much energy it takes to remove the outer electron for that element. And obviously, the higher the energy, the more energy you have to use to remove that. Now, that's today's lab, and let's look at the write-up. And if you look on the screen, here's the lab write-up. Again, it's in Blackboard. Notice for activity 1, What's your characteristic one? You arranged it. What's two? Did you see any trends or patterns? Now, where it says provided by your classmate, ignore that. Now, number one, you can answer. Number two, number three, where it says classmate again, ignore that. And yes, there are a number of questions you have to do, but this should go pretty quickly because all you have to do is rearrange these cards. Now, in activity two, again, where it says classmate, ignore. And same thing in question three, ignore, and question four. So wherever you see classmate in a question, ignore. Now in activity three, you'll answer the questions again. And finally, here, examples of representative periodic trends. These are what you're supposed to do in different organizations. And here you have some more questions to answer. Here in 1 through 5, actually 1 through 7, there are no classmate. Same thing through these. There's a lot of questions, but you're up to it, and I give you extra time. Now, one of the things I've done for today's lab, normally it would be due on Thursday if we had our lab on Tuesday. But because we have 4th of July, hold on, 4th of July tomorrow, and you should be celebrating the holiday. I hope you are. I've given you till I think Saturday or Sunday to finish today's lab. Same thing with Thursday's lab. That's because it's a holiday week and, you know, things go on. All right. Are there any questions about this lab? Don't forget, you need your kit, you need the cards. And while you're doing that, I'm going to put my cards away. Cards are away. All right, let's talk about test number 1. Everybody should have received an individual email from me showing how many points you received for each answer on test number 1. Now, listen closely. A student should never be penalized by a mistake I make when grading. I'm going to be going through all the answers on test number 1. If I've made a grading error, like it should have been 3 points and I only gave you 2, it should have been marked right and I marked it wrong, email me with what questions or parts of questions I made a mistake. I will go back probably Wednesday because tomorrow's the 4th. Ta-da! And I won't be doing any schoolwork tomorrow. It's a holiday. And I'm going to party hard, dude. But anyways, I will change that because a student should never, ever be penalized for a mistake I make on a test. Or even a lab too, if you ever have any questions about that. All right, now one other thing. I'm going to be cutting this out of the video. I like my special effects. I'm ambidextrous, I can do it both ways. But anyways, I'll be cutting it out of the video, the answers to test number 1, and I'll be posting it as a private video in YouTube, and I'll send you out a link so you can access it. I just don't want it out for the rest of infinity or time. And let's go to and that's test number 1. Now, first of all, I should tell you, which makes me feel good. See, I'm made my heart feel good, which is a good thing. By the way, don't forget 4th of July coming up tomorrow. The class average was 89.5 on test number 1. Thank you, class. Now, I have to warn you, test number 1 has usually the highest average of the semester. Not always, but usually. Test number 2 coming up in a while has the lowest average of the semester. So make sure you do the practice problems. On Wednesday, I'll be going through the practice problems for chapter 4. Now, question you might have is, what grade am I getting now? Well, let me open up something and I'll show you. If you look on the syllabus, you'll see grade cutoffs. And this also pertains to tests. If you got 90 and above, you got an A on test number 1. 80, 89 B, 70, 79 C, 60, 69 D, below 59 or 59 below F. Again, this is from your syllabus. However, a couple things I should remind you. What grade are you getting on the class? I'm assuming that you have been handing in all the labs. If you haven't, get them in. If you don't hand in labs, that really, really hurts your grade. Now, the other thing I should mention, the lowest test is always dropped. So each and every one of you can still get an A in this class. Some of you will have a little harder road to take because you dropped test 1, which is usually the easiest test, but I've seen students do that. Remember, you should be watching these videos, and you should, more importantly, do the practice problems on your own and hand in labs. All right, any questions? Wow, we got a
Yes, Professor. Sorry. I'm sorry, Dr. White. Will you be offering any extra credit at the end of the semester or anything?
just one.
Okay.
The one will be, are you ready for this? 10 bonus points.
Okay.
10 big ones. I like my special effects. Don't answer that.
Great job.
And it'll be right around after test 3, I usually do it.
Okay.
But the key thing is do the labs. People
Okay.
don't do labs. You're losing a lot of easy. When I say easy, you just do the labs and answer some questions. And it's at least 8 or 9 points out of 10, because most people can answer just about all the questions correctly. But that hurts your grade. Last semester, when I taught 1105 online like this, I had a number of students who didn't hand in a lot of labs. I had one student, this is sad, I didn't like it, but I had to go by my syllabus because they didn't do 6 out or 7 out of the 13 labs. They went from an A or close A to C. That was awful. They shouldn't, all I had to do was hand in the labs. What can I do? There's only so much I can do. All right, does that answer your question?
Yes, thank you.
You're welcome. All right, with that, let me close some stuff. Let me open chapter 5, part 1. And let me open one more thing. Now, last week, I started teaching about the mole. And I taught you that 1 mole of an element equals Avogadro's number. Avogadro's number is 6.02 times 10 to the 23rd. And in case of an element, 1 mole of an element is 6.02 times 10 to the 23rd atoms of that element. Now, for a compound, 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules of that compound. Now, don't forget, 6.02 times 10 to the 23rd is a calculated or measured number. And the one I use has 3 significant figures. Now, what you see on your screen is important information, test number 2. It's a file you can find in the lecture folder of Blackboard. I'll say that again. It's a file you can find in the lecture part folder of Blackboard. In the past, students would have to memorize the things on this piece of paper, important information. You don't have to for my class. Don't tell anybody I'm being nice. Shh. All right, we did some of these, but let's do one more. We're going to do it stepwise. And the question is, how many moles of H2SO4? You'll learn later in the semester. This is called sulfuric acid. I can spell it right. I tell you, I was always first one down in spelling bee. There. And sulfuric acid, I think, is the chemical produced the most in the United States. It's used for many things in chemical industry and other industries, H2SO4. So the first thing I'm going to ask you to do right here is figure out what are you being asked to find, what are you given? That's your turn. Do it now. I like that. Do it now. That's all I'm asking you to do. Don't do the whole problem yet. What are you being asked to find? What are you given? And let me start the poll again. Just answer yes when you're done. That's why I can't eliminate choice 2. Again, I'm not asking you to do the whole problem. Just what are you being asked to find? What are you given? All right, my turn. You're being asked to find, and I like to use a question mark, moles of sulfuric acid. What are you given? This number. So Once you have this done, you don't have to look back at the problem, and I won't. So there's only one number we have to start with. If there were some magic ratio that I could convert molecules of H2SO4, what units do we want our answer to be in? And I'll help you out. Moles of H2SO4. Now, what units go on top of the ratio? What units, not numbers, just units, go underneath the ratio? I'm going to let you try that first, because Dr. White likes to share the fun. Remember, just vote yes when you're done, or wait until you're done before you vote yes. Not asking for the numbers, just the units. And remember to use your good buddy, your good friend, unit analysis. All right, everybody's done. So it's time to use your good buddy, your good friend, unit analysis. And for many decades now, yes, decades, it's been my good buddy, my good friend. And whatever you're trying to get to unit-wise goes on top of the ratio. Whatever you're trying to get rid of, the units go underneath. And now I'll write those in. And where do I get these numbers? Well, in case you forgot, you can look at important information, test number 2. This will be on the last page of your test when you take test 2. This file is available in the lecture folder of Blackboard. You just got to scroll down near the end. And where do we find a relationship for a mole of a compound and molecules of a compound? Because H2SO4 is a compound. And the answer is 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules of that compound. And I'll write this again. This, you don't have to, but and remember, when you have two things equal each other, there are two ratios you can have. If A equals B, you can have A over B and B over A. So if we look right here, we want a relationship between moles of a compound, which would be the number 1, and molecules of a compound, which would be Avogadro's number. Now, before I pick up my calculator, actually I'm grabbing it right now, I'm going to check, do I get the correct units? And notice molecules of H2SO4 is divided by molecules of H2SO4, and anything divided by itself equals number 1. It's canceled out. And we're left with moles of H2SO4, which is what we want our answer to be. So now I'll turn on my calculator, clear it, put in 8.951 blue double E 65 times 10 to the 65th divided by Avogadro's number 6.02 blue double E 23. Oh, and I'm going to write it down here. My calculator gives me this number. Now, on test 2, like test 1, it will say, please use proper significant figures for all calculated answers. And this is 4 significant figures. 1, 2, 3, 4. All non-zero numbers are significant. This is 3 significant figures. 6 and 2 are significant. The 0's significant because it's after a decimal and it's confined. And the number you get is the same number of significant figures as the number you multiply and divide that has the fewest significant figures. I forgot to point out, 1 is part of the definition. It's an exact number not used to calculate it. Significant figures. What's the lowest number, 3 or 4? Hopefully I'll pick 3. So I'm going to let you round this off to 3 significant figures. And somebody's already done it correct, but I'll let all of you do. You've done it. So we keep the 1, keep the 4, keep the 8, use the 6 to round off. That's 5 or higher. So I'm going to drop this, all of these, and increase the 8 by 1. And the correct answer now will be 1.49 times 10 to the 42nd moles of sulfuric acid. And that's how you do this. And if I look at the clock, I knew we went a little over my normal time, take a break, but I wanted to finish this problem. So let's take a 5-minute break. We'll continue afterward. Don't forget, tomorrow, no class. It's the 4th of July. I'll get my money's worth out of this t-shirt today. With that, I'll see you in 5 minutes. I'm back. Don't forget, tomorrow is the 4th, so there'll be no lecture for Chem 1105 or any classes at COD. Also, tonight, even though tomorrow's the 4th, I will still have my office hour from 7 to 8 p.m. and I'll also have it on Wednesday at the same time. All right, let's get back to work. We've done our mole practice time, number 1, using our good buddy, our good friend, unit analysis. Let's move on. Now, there's a concept in chemistry called molar mass. Now, I use the term molecular weight. And what is the molecular weight for a compound? The molecular weight is the sum of all atomic masses or weights of all atoms in its molecular mass. What that means is you have to find the molecular weight of a compound, you add up all the atomic weights. Now, as I say here, I will call this molecular weight, and I'll use the abbreviation MW, molecular weight. Now, it's time for a special gift from Dr. White. As you see on the periodic table here, yep, you can see it, the atomic weight is the number underneath the element's name. For hydrogen is 1.008. Since you'll be using this periodic table, you don't have to memorize these. Thank you. For carbon is 12.011. Oxygen, 15.999. Now, to make your life easier, and by the way, when I've used molecular weights for calculations where a couple $100,000 in chemicals were riding on, did I do the calculation correctly? I'm still use what I'm going to have you use, which is my special gift to you. And that is test 2, test 3, test 4, and the final will say underneath your name, 1, please use proper significant figures for all calculated answers. And it will now say, please use 3 significant figures, 3 for all atomic masses or weights. And this will make your life easier. If we look at carbon, 12.011, round that off to 3 significant figures, it's 12.0. If we look at oxygen, 15.999, you round that off to 3 significant figures, it's 16.0. If we look at hydrogen, 1.008, round that off to 3 significant figures, 1.01. So for my test, and it will make your life easier, made mine easier when I do it for professional calculations, use 3 significant figures for all atomic weights. And let me have you try one. Sodium, Na, atomic number 11. Oh, that was strong water. Sorry about that. What would be the atomic weight of sodium, 22.989, the 3 significant figures? Your turn. All right, everybody's done. My turn. Keep the 2, keep the 2, keep the 9, 3 significant figures. And next, the number to round off is 8. Is that 4 or less or 5 or higher? And hopefully I'll pick 5 or higher. I'll drop the 8, drop the 9, increase the 0.9 by 1. That's 1.0. So for sodium, the correct atomic weight, the 3 significant figures, is 23.0. All right, now let's go back. Now that you know about atomic weights, the molecular weight of a compound is the sum of all atomic masses or weights of all the atoms in its molecular mass or weight. Now, one thing I want to show you, if you look at important information, test number 2, you'll be given this. The molecular weight of a compound is the sum of all atomic weights in that compound. In the past, you'd have to memorize that. Now you don't. You just have to know how to do it. So let's figure out how to do it. Let me make sure I don't have another slide. It's practice time. Let's calculate the formula mass, otherwise known as the molecular weight of water. So let's do water. How do we do that? And let me do this. So we have to calculate the molecular weight of water. The molecular weight of any compound is the sum of all atomic weights. Now, in water, H2O, there are 2 hydrogen and 1 oxygen. Now, what is the atomic weight for each hydrogen? And there's only 1 for each oxygen. Well, you have to go and look at the periodic table. By the way, I've been doing this enough decades, I know these by heart, but you don't. And hydrogen, the 3 significant figures is 1.01. Oxygen, the 3 significant figures, 16.0. Let's look at oxygen. How did I get 16.0? Keep the 1, keep the 5, keep the 9. Those are my 3 significant figures. The next 9 I used to round off. Is that 4 or less or 5 or higher? And hopefully I'll pick 5 or higher. I'll drop that 9 and then 1 afterward. The 9 after the decimal, I'll increase by 1. That becomes 1.0. 1.0 plus 15 is 16.0. So each hydrogen has a atomic weight, the 3 significant figures of 1.01. Each oxygen has atomic weight of 16.0. Well, we've got 2 hydrogen, so 2 times 1.02 is 2.02. I have 1 oxygen at 16.0. 1 times 16.0 is 16.0. The molecular weight is the sum of all atomic weights. So I'm going to add it up and I get 18.02. Now I have to teach you something that I didn't we didn't do when we were doing significant figures and math functions. This is an addition. You get the same number of significant figures to the right of the decimal as the number with the fewest significant figures to the right of the decimal. This has 2 significant figures to the right of the decimal. This has 1 to the right of the decimal. Which of those is the smaller number? Hopefully you all pick 1. And therefore, you have to round the numbers to the right of the decimal to 1 significant figure. Keep the 0. Use the 2 to round off. That's 4 or less, so drop it. So using atomic weights to 3 significant figures, the molecular weight of water is 18.0. Again, the molecular weight of a compound is the sum of all atomic weights. And in case you forgot, it's an important information, test number 2. And that file, or what you're seeing on your screen, is in the lecture folder of Blackboard with the hidden name, important information, test number 2. Oh, this was fun. We got to do another one. Oh, let's do ammonia, NH3. And the question is, calculate the molecular weight of ammonia. So calculate the molecular weight for B, 3 points each, ammonia. And how do we do that? Remember, the molecular weight is the sum of all atomic weights. We have 1 nitrogen. You look at the formula here. How many hydrogens? Yep, you're right. 3 hydrogens. Now, I have 3. And what's the atomic weight of hydrogen? The 3 significant figures? Well, we calculated that or determined that before. It's 1.01. Now we have, oops, I already wrote it down. We have 1 nitrogen. What's the atomic weight of nitrogen? Well, you go and look at your friendly neighborhood periodic table, and you see nitrogen N 14.007. On test 2, it will say, please use all atomic weights, the 3 significant figures. Now, I'm going to let you round that off to 3 significant figures, then I will. Time's up. Keep the 1, keep the 4, keep the first 0. That's my 3 significant figures. Use the next 0. Is that 4 or less? Yep, it better be. And therefore you drop that in the 7 and the 3 significant figures. The atomic weight of nitrogen is 14.0. I see somebody already beat me to it. Good. So we now know the atomic weight for nitrogen, the 3 significant figures, is 14.0. We're asked to calculate the molecular weight. That's the sum of all atomic weights. There's 1 nitrogen. 1 times 14.0 is this. There are 3 hydrogens. 3 times 1.01 is 3.03. By the way, if I ever make a mistake, let me know. And now the molecular weight is the sum of all atomic weights, and we get this number, 17.03. Now, underneath their name, test number 2 will say, please use proper significant figures for all calculated answers. This is calculated, and for addition, and this is addition, you get the same number of significant figures to the right of the decimal as the number that has the fewest significant figures. By the way, after decimal, everything is significant. So this 0 is one significant figure. 0.3 is two significant figures. Which one of these is a smaller number? And time's up. Hopefully you pick 1. So our final answer should have one significant figure to the right of the decimal point. Keep the 0. Use the 3 to round off. Is that 4 or less? Yes. So I'm going to drop that. And the correct answer using proper significant figures is 17.0. Oh, let's have couple more. These are good. Now, the next chemical, this is sodium hydroxide. The old name or common name is lye. How many of you have ever heard of lye soap? You haven't? Well, the settlers, and for many eons, to make soap, you would boil in water lye, sodium hydroxide, and animal fat. And that I'll teach you later on how that does that. And that makes soap. If you have bar soap at home, that's how it's made, from animal fat, or some of them nowadays are also vegetable oil. But sodium hydroxide, the question would be 3 points each. Calculate the molecular weight for sodium hydroxide. And the molecular weight, in case you forgot, is in important information. Test number 2, the molecular weight of a compound is the sum of all atomic weights in that compound. Well, sodium hydroxide has 1 sodium, 1 oxygen, and 1 hydrogen. Remember, you need, we'll say on test 2, please use 3 significant figures for all atomic weights. And sodium, the 3 significant figures, is 23.0. Oxygen is 16.0, and hydrogen is 1.01. So there's 1 sodium, 1 oxygen, and 1 hydrogen. And because there's only 1, I can just put down the atomic weight for each one to 3 significant figures. Oops, this should be a hydrogen. Sorry about that. And now add them up, because the molecular weight is the sum of all atomic weights. And if we add it up, we get 40.01. But we're not done, because in addition, you get the same number of significant figures to the right of the decimal as the number that has the fewest significant figures to the right of the decimal. On the left side, whatever number it adds up to, you don't touch that. That stays. So this is 1 significant figure to the right of the decimal. This is 1 significant figure to the right of the decimal. This is 2 significant figures to the right of the decimal. When you add or subtract, and I don't think we do any subtraction in this class, you get the same number of significant figures to the right of the decimal as the number with the lowest, and that's 1. I'm going to let you round this off to the proper answer, and then I'll do it. So it's your turn to have some fun. I don't want to hog it all. when you're done, please vote. Yes. Again, all I'm asking you to do is what's the proper answer, because 40.01 is not. All right, everybody's done. You should have one significant figure, because that's the lowest number of significant figures of the numbers you're adding to the right of the decimal. Keep the 0. Use the 1 to round off. It's 4 or less. I'll drop that. And the correct answer here is this, 40.0. And it looks like everybody's getting the right answer. Yay! Thank you. So we've done our practice time. Remember, the molecular weight is the sum of all atomic weights. Now, the question is, well, why do I calculate something like this? Well, it's time to find out. There's something called molecular mass, and the elemental molar mass is the quantity in grams. Don't write this down. I'll never ask this on a test. Is the quantity in grams of an element that equals the atomic mass of that element. Now, there's for a molecule, we call it the molecular mass or molecular molar mass, and that's the quantity in grams for a formula mass or molecular weight of a molecule equals the formula or molecular weight of the molecule. Now, these definitions are from your book, but you don't have to buy the book because I've helped you out. Now, what that really means is here, and again, this is important information. Test number 2, you'll be given 1 mole of an element equals the atomic weight of that element in grams. Now, in this class, we'll do grams. You can do other units like pounds, and I've done that. But for this class, we'll stick to grams. And also, 1 mole of a compound equals the molecular weight of that compound in grams. And this concept is extremely powerful. And I'll teach you later on this chapter how powerful it is. But let's look at a problem. Oops. Now, throughout the rest of the semester, a lot of times for grams, I'll just use the letter G. Again, through the rest of the semester, for grams, I'll just use the letter G. So how many grams of water are how many grams of water are 8.667 moles of water? And by the way, it can be 8 to 10 points each. Yes, 8 to 10 points each. So the first thing I'm going to do is figure out what am I being asked to find? And the answer is grams of water. Remember, I use the letter G to mean grams. That's standard in chemistry. And what are we given? .667 moles of water. So we only have this number. Once I have this, I do not have to look back up here at my word problem. Relax. Yes, it's a word problem. Take a deep breath. You'll learn how to do these. always find out what are you being asked to find, what are you given? Well, we've done that. Well, this is the only number I have to start with. If I had some conversion factor ratio, what units do I want my answer to be? And the answer is, we figured it out, grams of water. And what goes on top and bottom of this ratio? Well, it's time to use your good buddy, your good friend, unit analysis. Hope you all like my whistle. I do. And whatever we're trying to get to, the units go on top of that ratio. Whatever units we don't want in our answer, we want to get rid of, the units go underneath that ratio. And I'll write them in. And where do I find this stuff? Well, where do I find a relationship between grams of a molecule and moles of a molecule? And right here, 1 mole of a compound equals the molecular weight of that compound in grams. Oh, I need the molecular weight. And the molecular weight of a compound is the sum of all atomic weights in a compound. So for every 1 mole, we have the molecular weight of that compound in grams. Well, wait a second. We don't have the molecular weight. Well, you have to know how to calculate the molecular weight of the compound. And remember, the molecular weight of a compound is the sum of all atomic weights. That's why we just went through that. So what I need to do is I need to calculate the molecular weight of water. How do I do that? It's the sum of all atomic weights. 2 hydrogen, 1 oxygen. We earlier found that the atomic weight of hydrogen, the 3 significant figures, is 1.01. The atomic weight of oxygen, 16.0. Do the multiplication, I get this. It's the sum of all atomic weights. So I'm going to add these 2 numbers together. Remember, for an addition, you get the same number of significant figures to the right of the decimal, number with the fewest significant figures to the right of the decimal. And this would have 2 significant figures. This is 1, keep the 0, use the 2 to round off, is 4 or less. So the correct molecular weight of water is 18.0. And 1 mole of water equals its molecular weight, 18.0. And now, before I pick up my calculator, it's right down here, I'll see moles of water divided by moles of water. Anything divided by itself equals the number 1. And therefore, this cancels out. I'm left with grams of water, which is what I want for my answer. So now I can pick up my calculator, turn it on, clear it. I have 8.667 times 18.0, hit enter, and my calculator gives me this number. $1.56006 times 10 squared. Now, on test 2, like test 1, it will say under your name, please use proper significant figures for all calculated answers. For multiplication division, you get the same number of significant figures in your answer that has the fewest significant figures in your answer. And if we look here, we have 4 significant figures. All non-zero numbers are significant. Here we have 2 non-zero, and a 0 after decimal is significant. So the 18.0 is 3 significant figures. Which is the lowest number, 3 or 4? And hopefully I'll pick 3. So now you have to round this off to 3 significant figures. I'll let you try that, and then I'll do it. Round 1.56006 times 10 squared to 3 significant figures. I see somebody's already done it right. But let's give everybody time to think about it. They're done. So keep the 1, keep the 5, keep the 6. Use the 0 to round off. Is that 4 or less? Yes. So I'm going to drop that, that, and that. And the correct answer here is 1.56 times 10 squared grams of water. Now, the nice thing about this is if I needed 8.667 moles of water for some reason, I can't count molecules because I don't know about you. I don't have X-ray vision. Do you have X-ray vision? Can you see all the molecules in here? I know they're there, but I can't see them. Nope, I can't. Hold on. Let's shine some light on. By the way, I'm a flashlight collector. This comes from the best flashlight maker in the world. This one guy in China, Hank Wang, and I have a collection of his stuff and others too. And with light on there, nope, you can't see the molecules. And therefore, how do you get moles of water? Now you know, you can weigh it out. All right, let's do another one. Depending on my mood when I'm writing test number 2. All right, the question is, how many moles NH3? This is ammonia. It's a very important chemical in our daily life. Are 4.13 times 10 to the third grams of ammonia. If I look at the clock, well, we got plenty of time to finish this up. All right, I'm going to ask you first, what are you being asked to find? What are you given? Your turn. We're going to do this stepwise. You're only being asked, what are you given? What are you being asked to find? All right, my turn. Isn't it nice I share? All right, we're being asked how many moles of ammonia. And you don't have to put the S there. In fact, nowadays they don't even put the E there. They just have MOL for mole. Now, I learned it the old way with an E. You can do it either way. What are you given? 4.13 times 10 to the third grams of ammonia. Well, The only thing we have to work with is this number. And let's do it stepwise. Over here, what units do you want your answer to be in? I'll give you time to figure it out, and then I'll do it. Again, all I'm asking you is what units do you want your answer to be in? All right, everybody's done? Well, we took the time to figure that out right here. That's why I put a question mark. So we have moles of ammonia. Let's try this H again. That looked ugly. That's better. Now, in this ratio, what units do you want on top? Not numbers, this what units? Your turn. What units do I want on top and what units go underneath? And don't forget to use your good friend, your good buddy, unit analysis. Again, I'm only asking the units. All right, everybody's done. So, by the way, those people at home, if you need extra time, push the pause button on YouTube video. Now you can push it back going. All right, it's time to use your good buddy, your good friend, unit analysis. Whatever we're trying to get to, the units go on top of that ratio. Whatever we're trying to get rid of, we don't want grams of ammonia in our final answer. We just want moles, goes underneath. And I'll write that in. And where do we find a relationship between moles of a compound, in this case ammonia, NH3, and grams of a compound? Well, important information, test number 2. In the past, students would have to memorize this. You don't. And the question is answered, 1 mole of a compound equals the molecular weight of that compound. Oh no, we're not given the molecular weight, but same important information. Test number 2, remember this file is in the lecture section of Blackboard near the end. 1 mole, the molecular weight of a compound, is the sum of all atomic weights. So we need to find out the molecular weight of ammonia. And it's the sum of all atomic weights. And we have, whoa, what happened to my, let's try this again. We have 1 nitrogen, 3 hydrogen. And we did this already, so I'll go a little quicker. Each nitrogen to 3 significant figures is 14.0. Each hydrogen, there are 3 of them, to 3 significant figures is 1.01. 1 times 14.0 is this. 3 times 101 is this. It's the sum of all atomic weights, so I'm going to add it up. When you do an addition, you get the same number of significant figures to the right of the decimal as the number it has the fewest. All numbers 0 or whatever to the right of the decimal are significant. This is 1, this is 2, which is a smaller number. Hopefully you pick 1. So now we round this off to 1 to the right of the decimal. Keep the 0, use the 3 to round off. It's 14. When I'm getting ahead of myself, is 3, so I'm going to drop that, and you get 17.0. So for every 1 mole of ammonia, there's 17.0 grams of ammonia. Now, before I pick up my calculator, I'll check to my unit, do I get the right units? Notice grams of ammonia divided by grams of ammonia. Anything divided by itself is the number 1. It cancels out. I'm left with moles of ammonia. Yay. So now I'll pick up my calculator, turn it on, clear it. 4.13 blue double E, meaning 10 to the 3rd, divided by 17.0. And my calculator gives me this wild number. I mean, wild, like it's a lot. This. Now, you get the same number of significant figures in your answer that the number you're multiplying, dividing by has the fewest significant figures. This is 3 significant figures. Oh, this is 3 significant figures. The 1 is an exact number, part of the definition, so it plays no role in significant figures. Which of those 2 numbers is the lowest? Well, they're the same. So now you need to round this off to 3 significant figures. I'll do it because we're all about out of time. Keep the 2, keep the 4, keep the 2. Use this number to round off, 9. Is that 4 or less or 5 or higher? And 5 or higher. I drop everything afterward, increase this by 1. And my answer for this problem will be, we went down here, 2.43 times 10 to the squared moles of ammonia. And that's how you do it. We'll do some more on Wednesday because I've gone a whole 2 minutes over. Oh no, I'm sorry. All right, first of all, everybody have a happy 4th of July. Remember, there's no lecture tomorrow. And the lab we did today, yay, thank you, Judith. The lab we did today normally would be due Thursday, but because tomorrow's a holiday, yay, 4th of July, I get my money's worth out of this t-shirt. I've extended the due date for the lab we're due today that we normally would have done tomorrow. And I extended the due date for Thursday's lab because it's a holiday week. You're welcome, Judith. And remember, I have my office hours tonight from 7 to 8 p.m. Also on Wednesday night. If you need help, let me know. If you can't make it to my office hours because you're working, email me and we'll see if we can set up a private time on Zoom when I can help you out. With that, I'll say tomorrow, everybody have a happy 4th of July. Hopefully you get to see some good fireworks. If not, go to YouTube, but it's not the same. And thank you, Angelica. And I think I pronounced it right. With that, I'll say, Gang gesund, goodbye. I stole that from Granny and the Beverly Hillbillies. Bye.